Good afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, we are going to study our new chapter. It's nothing but sequences and series, right? Sequences and series. So, here, sequence and series, it's a very important chapter with respect to JEE main. So, on sequence and series, there are questions will be asked. So, basically, what do you mean by sequence and series? Let's see what is sequence and series. In general, we can say sequences. In order, we can say sequence means in order. Usually, we can say while doing a parade or a morning walk, or you can take any example or prayer in your school if you are doing in a morning prayer. So, you will stay in sequence one by one with respect to your height, right? So, it is an order. Class wise we can say first class, second, third, fourth, fifth, so on, like this you will stay or you will stand in a sequence, right? So we can see the definition of sequence here. First, sequences, that is the arrangement of numbers formed according to some specific order. See here, some specific order is called a sequence, is called a sequence. See what it says. The definition of sequence is the arrangement of numbers formed according to some specific order is called a sequence. There must be a, and there must be what, a specific order, we can say this term. The specific order is nothing but what, our sequence. Arrangement of numbers according to some specific order is nothing but a sequence. The next line, in a sequence, in a sequence of numbers, in a sequence of numbers, a1 comma a2 so on up to an, if nth term, if the nth term an is known, right? Nth term is an is known, then n plus 1th term, n plus 1th term, that is a n plus 1, can be determined, right? So nth term is an, n plus 1th term is an plus 1. Usually we can denote in a sequence numbers as a1, a2, a3, so on up to an, right? So nth term we can say usually an, right? So for example, let's see the sequence examples. For example, 1 comma 2 comma 3 so on dash 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 is a sequence. It's a set of natural number. There will be a specific order is there. Just we are adding 1 to the previous term. So it becomes 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, so on up to, right? So it's a sequence. So similarly, if I take one more example, that's nothing but 2 comma 2 by 3, 2 by 9, 2 by 27, dash dash so on is a sequence. It is also sequence because 2 by 1 is 2 only here, right? So 2 by 3, 2 by 9, 2 by 27, just we are squaring the term here. 3 square is 9, 1, 3, 9, 27, right? Simply it is in sequence. In sequence we are changing the terms, or simply we can say multiplying by 3 in the denominator. Numerator 2 is as it is. In the denominator we are multiplying by 3. 1 3 is a 3, 3 3 is a 9, 9 3 is a 27, 23, 27 3 is a so on like this. So it becomes a sequence. So in other term, a sequence can also be defined as in other form. How we define? Let's see. A sequence is also defined as a function here. See, a function from the set of natural numbers to set of real numbers, we can say, right? A sequence is also defined as a function from, simply we can say a function from set of natural numbers to, it is a function, right? Set of natural numbers to real numbers. It is also a sequence, we can define in the sequence. So now we conclude what is sequence. So next we come across the series. Next one is series, right? So here series is nothing but the sum of all the sequence. In general we can say the sum of all the sequences what we have in a sequence is nothing but a series. Let's see its definition. If if a1 comma a2 comma a3 so on up to an dash 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 is a sequence, then the expression then the expression a1 plus a2 plus a3 plus a4 so on up to an plus dash 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 is a series. What we have done here, just we have added the terms which are in sequence, or you can say in specific order, what already we have seen in sequence it is, right? So the sum of all the sequences, that is a1 a2 a3 so on up to an dash 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 is a sequence we are saying here. So then the expression a1 plus a2 plus a3 plus a4 so on up to an plus so on is a series, right? A series is finite. The next, a series a series is finite or infinite according to according as the of number of terms in the corresponding sequence is finite or infinite. what it says. A series is a finite or infinite according as the number of terms corresponding to the sequence. How many number of terms are present in that sequence? Based on that we can assign, or we can say the series is finite or infinite, right? Let's see the example. 1 square, 2 square, 3 square plus dash 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 1 plus 3 plus 5 plus so on dash dash. It is a series, definition of series with respect to examples, right? So now we conclude what is series and what is sequence. Simply, a sequence is the arrangement of numbers formed according to some specific order. There must be some order. Then we can say it is a sequence. Usually sequences are denoted by a small letter A1, A2, A3, so on up to AN. If the nth term is AN is known, then the n plus 1th term is AN plus 1. It is n plus 1 is base of A, right? A to the base n plus 1 can be determined easily. So examples already we have seen, and the definition of sequence in other form, that is nothing but a sequence is also defined as a function from set of natural numbers to set of real number, that is f from n to r is a sequence, right? So series already you know, that is if a1 a2 a3 so on an is a sequence, then the expression a1 plus a2 sum, that is addition of all the sequences, is nothing but our series. Or a series, there are again finite and infinite. So according as the number of terms which are present in a sequence, based on that we can calculate whether it is finite or infinite series, right? So next we will come across arithmetic progression, AP. Next, third one is AP, arithmetic progression. Let's see the next definition. Arithmetic progression. It is nothing but in short we can say AP, right? So what is arithmetic progression? Let's see. A sequence A1, A2, so on up to AN dash 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 is called an arithmetic progression. Arithmetic progression if difference of any term, and its previous term is always a constant, is always a constant. That is, the constant difference is called the constant difference is called the common difference. Common difference, that is nothing but d of the arithmetic progression, that is AP, right? That is A2 minus A1 equals to A3 minus A2 dash dash dash, which is equals to D, which is equals to any term minus previous term, which is equals to a constant value, that is nothing but D we can say, right? Here If A is a first term, if A is the first term, is the first term, and D is the common difference, then the AP will be of the form, the AP will be of the form A, A plus D, A plus 2D, A plus 3D, so on. Then the nth term of the AP is given by Tn, which is equals to A plus of n minus 1 D, right? It is the nth term of AP. Now let's see what is arithmetic progression once again. It is nothing but a sequence A1, A2, so on up to C. Arithmetic progression, that is AP. A sequence A1, A2, so on up to AN is called an arithmetic progression. Already you know what is sequence. Arrangement of numbers in a specific order, right? So a sequence A1, A2, so on AN is called an arithmetic progression if the difference of any term and its previous term is always a constant. Any term, its previous term, any term and its previous term is always a constant. There will be a constant. If you take any two numbers, then there will be a difference between those two numbers must be a constant, same constant. You can take in a sequence any number. A1, A2, so on up to AN is there here, right? If you take A2 minus A1, then there will be a same constant. If you take A5 minus A4 or A10 minus A9, or you can take AN minus of 1. So then there will be a difference is what? A constant difference should be maintained. Then we can say it's an arithmetic progression. And the constant difference is called a common difference. That is nothing but we can denote it by D. A constant difference D. We can take any two numbers. There must be a constant difference and it is denoted by small d in AP, right? So now let's see. That is A2 minus we have taken here. A2 minus A1, which is equals to A3 minus A2. So again, which is equals to A4 minus A3, so on dash 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 up to, which is equals to what? D. A difference between any two terms is nothing but D, that is a constant difference. Therefore, we can say it as any term minus of previous term. Then the value which is equals to what? The common difference, that is D again here, right? So if A is the first term and D is a common difference, then the AP will be of the form. Then we can form, if A is the first term, we can say, then D is the common difference, already we know. Then the AP will be of the form A, A plus D, A plus 2D, A plus 3D, so on up to if we go, then the nth term of a AP is given as Tn, that is the nth term, right? Tn is nothing but nth term, which is equals to A plus of n minus 1 D is nothing but our nth term of arithmetic progression, right? So now next some properties are there, properties of arithmetic progression we will see in the next class. So till then, take care, stay at home, stay safe. Thank you.